Now, we study detailed explanation for this demand and supply change, right? Using elasticity concepts. Before explaining this, I'd like to explain some notation, right? I'd like to use, this one. So notate this one is change, right? Change. So change in price is equal to price of ending value minus price of starting value, right? Change in demand is ending value of quantity demand minus starting value of quantity demand. That is change in quantity demanded. Similarly, change in quantity supply is ending value of supply minus starting value of quantity supplied. Okay? So that is change concept. And also then, what is slope? In usual economics graph, for example, y variable is price, and x variable is quantity demanded or quantity supply is need. So demand curve is like this, right? Then slope, changing rate of quantity demand is like this. Slope of this graph is y variable is p. So change in price over change in QD. That is a slope of this graph usually, right? That is this kind of concept, right? Now think about from here. And now I'd like to explain percentage change, right? Percentage change. So percentage change means like this. Percentage change in price is equal to change in price, I'm explaining here, divided by price. For average price or some certain price, average price usually for simplest purpose, right? That is percentage change concept, right? Similarly, percentage change in quantity demanded is equal to change in quantity demanded, I already explained here, divided by price. That is percentage change, right? Using this, we can define price elasticity of demand. Price elasticity of demand is like this. Price elasticity of demand is equal to percentage change in quantity demanded over percentage change in price. That is definition of price elasticity of demand, right? So this one is expanding this percentage change in what is this? Quantity? Something. What is this? Percentage change in quantity demanded is this one, right? Is this one. So change in QD over price. Percentage change in price is change in price over price. That is QD, like this. Right? So, rewriting this one is equal to change in quantity demanded, percentage change in price, right? Multiplied by price. Price, quantity demanded is like this. That is definition of price elasticity of demand, right? Then we know that compare this one, and in this figure I explaining that slope of that curve, change in P over change in quantity demanded. But in elasticity terms, one component of price demand is this one, the reciprocal value of this one. Okay? So should be careful for that. this one. Right? Now we go back our slide. Price elasticity of demand, the percentage change in quantity demanded of a good resulting from a 1% increase in its price. So like this. When price increases by 1%, how many percent of quantity demanded changes? Replacing this one, we can get this one. Right? I already explained this. Look at this figure, linear demand curve. That means slope is same. Slope is same. If demand curve is Q equal A minus B price, then from here, change in P over change in P over change in Q is minus 1 over B, right? So from here, demand curve is minus 1 over P, right? Linear demand curve. So the reciprocal value of this one is this one. So this one is minus B. Anyway, in this graph, have same slope of this one, change in P over change in Q, same. That is, for example, minus 1 over B, isn't it? But in this price elasticity of demand, this term, right, blue term is reciprocal value of this. This one is minus 1 over B in our textbook. Then this one is minus B, right? So at this point, or at this point, or at this point, or at this point, anyway, changing rate is same to minus B, same. But when we moving from here to here, what happened? Here to here, price decrease and quantity demand increase. When we moving here to here, price decrease again, quantity supply increase. So this one decrease and quantity demand increase when we moving this direction. So in spite of same value of this change in QD over change in price, this one decrease and decrease and decrease. So price elasticity of demand at this point, decrease and decrease and decrease. At this point, price elasticity of demand is minus infinite, right? This point, minus 1, this point, 0. So in absolute terms, this one decrease and decrease and decrease, right? In absolute terms. That is explained here. The price elasticity of demand depends not only on the slope of demand curve, or this one, right? And price and quantity changes. Slope is constant for this linear demand curve. Near the top, because price is high and quantity demanded is small, elasticity is large in absolute term. The elasticity becomes smaller as we move down the curve in absolute terms. Okay, now we go next slide. So we can see special case, right? This kind of thing. Horizontal demand curve. Horizontal demand curve means this one is equal to 0, right? That means this term is equal to minus infinite. So price elasticity of demand is minus infinite in this case. So we said infinitely elastic demand. Principle that consumers will purchase as much of good as they can get at a single price. But for any higher price, the quantity demanded drops to 0. While for any lower price, the quantity demanded increases without limit. Right? So slope in this figure is equal to 0. And price elasticity of demand is minus infinite. Okay? Now, just the opposite case. Completely inelastic demand curve. Now think about this. Change in price over change in Q is equal to infinite, right? This one is infinite number. So this one is equal to 0, right? Price elasticity of demand is equal to 0. For a vertical demand curve, change in Q over change in price is equal to 0. Because the quantity demanded is the same no matter what the price, the elasticity of demand is equal to 0. We set completely inelastic demand. Principle that consumers will purchase a fixed quantity of good regardless of its price. Two extreme case, right? So think about this income elasticity of demand. What is the income elasticity of demand, right? Income elasticity of demand, where I can write. Is it possible here to write here or there? This one. So income elasticity of demand, right, is equal to percentage change in quantity demanded when income, percentage change in income, right? So income increased by 1%, then how many percent of quantity demanded changes? Rewriting this one is changing QD over change in income multiplied by income over quantity demanded, right? So now look at this demand function. This income increased by 1%. Then how many percent of quantity demanded changes increase? Usually increase like this, right? Also, cross price elasticity of demand is possible. Price of J, other good, price of other related good changes. This one changes, then what happened in quantity demanded? That is cross price elasticity of demand. That is equal to percentage change in quantity demanded over percentage change in price of related good, other good, PJ, right? So rewriting this, anyway, same thing. If this is a positive, substitute. If this one is positive, then substitute. We already studied the concept of substitutes, right? If this is negative, then complements, right? Think about as price increase, then demand for coffee bun also coffee bun decrease, like this. Then we set complements. That is price elasticity of cross price elasticity of demand. Finally, we can define price elasticity of supply. That is related to supply from curve, right? So this one, for example, this one increased by 1%, then how many percent of quantity supply happen? That is price elasticity of supply. That is rewriting this. The concept is very same to this, right? So I'd like to use that one, right? This one. Then price elasticity of supply is percentage change in quantity supplied by percentage change in price, right? How many percent change of quantity supply changes when price increased by 1%, right? Rewriting this one is change in QS over change in price multiplied by price over QS, right? And now think about supply curve. Supply curve is like this, right? Usually price and this is a quantity supply. Slope of this curve in this figure set change in price over change in QS. That is some constant numbers where this is a linear, right? And this one is the reciprocal value of the slope of this curve, right? Reciprocal value of this one. Anyway, same, constant, right? So supply curve also changes. Price elasticity of supply decided by this one and this one, right? We go back our slide. Price elasticity of supply, percentage change in quantity supplied resulting from a 1% increase in price, right? Point versus arc elasticity. Point elasticity of demand. Price elasticity at a particular point point on the demand curve, one, right? So elasticity at this point or this point, like this. But arc elasticity is when you're moving here to here, then we can calculate it in this range, right? Then usually everything is changing the same in linear case, but price quantity is average value of quantity. For example, is QD is this one. QD is average value of starting value of QD, ending value of QD, right? Price same. P bar means starting value, average of starting and ending value of price. That is P bar. That is arc concept, arc elasticity concept, right? So like this. Okay, now we go example. The market for wheat in the United States. During the case, change in wheat market has major implication for both American farmers and the U.S. agricultural policy. To understand what happened, let's examine the behavior of supply and demand beginning in 1981. Supply curve is like this. QS, supply curve is like this. Demand curve is like this. Right? So, by setting quantity supplied equal to quantity demanded, at equilibrium price, quantity demanded should be equal to quantity supplied. Quantity supplied is equal to quantity demanded at equilibrium price. Then we can calculate equilibrium price, right? That price is $3.46 per bushel. If this one is inserting here or demand curve or supply curve, we can calculate equilibrium quantity. That is this one, right? So in tests, and usually you have to calculate like this. Then we use a demand curve to find the price elasticity of demand, right? Price elasticity of demand. So equilibrium price, we already calculated. $3.46, equilibrium quantity, this unit, right? And lefting the remaining part is this one, change in QD over change in price, right? This one is minus 266. How do we know this? Now look at this, right? QD is this one. So change in QD over change in price. First derivative of this demand function set minus 266, right? So like this. So then we can calculate price elasticity of demand is equal to like this. Also, we can calculate price elasticity of supply at that equilibrium point, right? So same thing. Equilibrium price, same to this one. Equilibrium quantity, same to this one. But slope, right? Different. 240. Why 240? Now look at this. Supply curve is like this. Where is supply? I'm sorry. Supply curve is like this, right? So changing QS over changing price, changing QS over changing price is 240. This one inserted here. Then we can calculate price elasticity of supply is this one. Got it? How to win? So practice yourself, right? Suppose that a drought causes supply curve to shift far enough to the left to push the price up to $4 per bushel. Price now $4. Price is now $4 because of drought. In this case, the quantity demanded would fall to this one, right? So we calculate demand curve is price is something. Then we can calculate new quantity demanded, right? I'm sorry, supply curve. New price is $4. Then $4. Then new quantity supply is calculated like this. Also demand like this, right? Then price and quantity new quantity and new equilibrium price, new equilibrium quantity, but the slope, changing quantity demanded over changing price, same. Then we can calculate elasticity become minus 0.43 from here to here. Okay? In 97, demand and supply were like this. Market clearing condition, this one is equal to this one, then we can calculate like this. So quantity demand like this, right? So anyway, you practice. Anyway, this is the example, right? You practice for yourself in your note. Okay, now we go next graph. The market for wheat. The price of wheat in the United States. The price of wheat fluctuates in response to the weather and the change in export demand. X variable is time, year. Y variable is, I cannot read, real price and nominal price. And blue one is real price, like this, right? Fluctuate like this. From here we know that price decrease a little here. Basically, not so price doesn't fluctuate, but the range is not so big, right? Now we go section 5, short-run versus long-run elasticity. In the short-run elasticity is different from long-run elasticity. Usual example of this, demand for gasoline, short-run and long-run, right? Demand curve in the short-run is like this, gasoline price, long-run, right? In the short-run, an increasing price, increasing price has only a small effect on the quantity of gasoline demanded. Right? Why? Just consumer can do is what the consumer can do is drive less. Right? In the short run. But in the long run, in the short run, so drive less, but they will not change the kinds of cars they are driving overnight. Right? So short run demand curve is like that. But in the long run, however, in the long run, in over 10 years, for example, they have more options. They will shift to smaller cars and more fuel efficient car because gas price increase, right? So in the long run, consumers so decrease demand greatly than in the short run. The effect of the price increase will be larger. The demand, therefore, is more elastic in the long run than in the short run. That is the usual case. Long run elasticity is larger than short run elasticity. Okay? Long run elasticity greater than short run elasticity in the demand. Okay? Usually, long run elasticity greater than short run elasticity in absolute terms, right? But in this case, demand for durable goods, short run elasticity larger than long run elasticity, the opposite of usual case, right? So look at this. Demand for automobile. Automobile is durable goods. Short run and long run demand curve in this case. The opposite is true for automobile demand, durable demand, right? If price increase, consumers initially defer purchasing new cars. Thus, annual quantity demanded falls sharply in this case. In the long run, however, old cars wear out and must be replaced. Consumers have no other option but to change, but to purchase, right? Thus, annual quantity demanded picks up. Demand, therefore, is less elastic in the long run than in the short run. That is durable goods, demand for durable goods case. In the earlier slide, demand for non-durable goods. In that case, long run elasticity larger than short run. But the opposite is true in the case for demand for durable goods. Now we go income elasticity. Income elasticity also differ from short run to the long run. For most goods and services, foods, beverages, fuel, entertainment, and so on, the income elasticity of demand is larger in the long run than in the short run. That is the usual case. Same to price elasticity of demand, right? But in the case of durable good case, the opposite is true. The short-run income elasticity of demand will be much larger than the long-run elasticity. Okay? So durable good, non-durable good, different. Now think about cyclical industries. Cyclical industries means industries in which sales tends to magnify cyclical changes in gross domestic product, GDP, and national income. Right? GDP and investment in durable equipment. So durable equipment, for example, investment, right? Annual growth rates are compared for GDP and investment in durable equipment. The fluctuation of equipment in investment, durable goods, right? And normal GDP is this one. So fluctuation in equipment investment is larger than GDP, right? Because the short-run GDP elasticity of demand is larger than the long-run elasticity for long-lived capital equipment, durable equipment. Changes in investment in equipment magnify change in GDP. Thus, capital goods industries are considered cyclical. Got it? Next slide. Consumption of durable versus non-durable, right? So almost same to earlier one. So time and growth rates, right? Non-durable good case is very fluctuation, very severe in durables, but non-durables like this. GDP is in the middle of them. Annual growth rates are compared for GDP, consumer expenditures on durable goods, automobiles, appliance, furniture, etc., and consumer expenditures on non-durable goods. For example, demand for food, clothing, services, like this. That is a usual case, right? Where long-run elasticity is larger than short-run. But in this durable good case, short-run elasticity larger than long-run elasticity. Because the stock of durables is large compared with annual demand, short-run demand elasticity are larger than long-run elasticity. Like capital equipment, industries that produce consumers' durables are cyclical. Right? For example, change in GDP are magnified. This is not true for producers of non-durable. That is the usual case, right? Non-durable case, but durable case, very cyclical. Fluctuation, severe, very severe, like this. Example 2.6, the demand for gasoline and automobile. So we already studied this kind of thing. For example, demand for gasoline, demand for non-durable goods, or usual case. And elasticity after 1 year, 2 years, 3 years, 5 years, 10 years, right? So now think about price elasticity of demand, 1 year, 0.2, 2 years, minus 1.3, after 3 years, minus 0.4. So price elasticity of demand increase and increase, right, as time passes. In other words, long-run elasticity larger than short-run elasticity in absolute terms. That is the usual case, non-durable goods case, right? Income elasticity is the same. Short-run elasticity in long-run elasticity larger than short-run elasticity. So after time passes, income elasticity also increase, right? Like price elasticity of demand. That is the usual case, or demand for gasoline case. Now we go demand for automobile, or durable demand for durable cases. Number of years are allowed to pass following a price or income change. Price elasticity of demand in durables, in absolute terms, decrease and decrease over years, over period, right? Income elasticity same. In absolute terms, decrease and decrease and decrease in durable case. Ordinary case, durable case. Just the opposite, right? Next slide. Short-run versus long-run elasticity. Supply, right? Supply and durability. Figure 2.17. Copper, short-run and long-run supply curve. Like that of most goods, the supply of primary copper shown in part A is more elastic in the long run. Long run elasticity larger than short run elasticity in the supply of copper. Right? If price increase, firms would like to produce more, but are limited by capacity constraints in the short run. But in the long run, anyway, company can purchase more capital, for example, more labor, and supply of goods increase greatly. So long run elasticity larger than short run elasticity. In the long run, they can add to capacity and produce more. So long run supply curve is like this, right? But now think about secondary copper, right? No secondary copper? Okay. Part B shows curves, supply curves for secondary copper. If the price increase, recycled copper, recycling of copper, for example, right? If the price increase, there is a great incentive to convert scrap coppers into new supply. Initially, therefore, secondary supply increased sharply. But later, as the stock of scrap copper falls, so thus secondary supply contracts. In this example, in secondary copper supply, short run elasticity larger than long run elasticity, just the opposite of earlier case, primary copper case. Secondary supply is therefore less elastic in the long run than in the short run. Right? Now, table 2.3, supply of copper. Primary supply, ordinary case, and secondary supply, so opposite case, and this total supply. Short run elasticity 0.2. Long run elasticity 1.6 in the case of primary supply. So we know that long run elasticity greater than short run elasticity in this primary copper supply, right? But in the secondary copper supply case, short run elasticity greater than long run elasticity, right? Just the opposite of primary supply case. So finally, total supply, primary supply plus secondary supply, short run elasticity, long run elasticity, right? Okay, then we move example 2.7. The weather in Brazil and the price of coffee in New York City, right? So look at this figure, time, year, and nominal price. Nominal price increased greatly, right? But in the long run, price tends to show a decreasing trend, right? Real price decrease in the long run. Why that happen? Price of Brazilian coffee. When droughts or freeze damage Brazil's coffee trees, then supply of coffee, exportation of Brazilian coffee to United States market decrease greatly. So price of coffee increase greatly, can soar in the short run, right? The price usually falls again in the long run after a few years as demand and supply adjust. So price of coffee showing decreasing trend in the long run. So look, we studied this in this figure. That is the impact of weather in Brazil in the very short run, in the intermediate run, in the long run. In the intermediate, So in the very short run, demand is like this. Supply decrease, shift to the left, decrease greatly. In the very short run, right? So price increase greatly, like this. But intermediate run, elasticity, price elasticity and price elasticity of demand and supply shaped like the increase like this. So same effect of weather in Brazil result in increase in price smaller than this case in the very short run. Quantity like this, small impact. Price and quantity impact is smaller than in the very short run. Okay? In the very long run, then what happens? Supply can adjust in the very long run. So supply is like this. And demand elasticity also increase. So supply curve shifts to the left, but same. So no change in price, no change in quantity, equilibrium quantity. So in the very long run, in the intermediate run, and in the very short run, quite different, right? A freeze or drought in Brazil causes supply curve to shift to the left. In the short run, in the very short run, supply is completely inelastic, like this. Only a fixed numbers of coffee beans can be harvested. Demand is also relatively inelastic, so like this, right? Consumers change their habit only slowly. As a result, the initial effect of freeze is a sharp increase in price, P0 to P1, right? Like this. In the intermediate run, supply and demand are both more elastic, so smoother than before, right? Compared to this one and this one. Demand curve, smoother than before, higher elasticity, right? So in the intermediate run, price falls part of the way back to P2 in the long run, right? P0 to P2. So price increase, but smaller than increase in price in the very short run. Quantity, like this, right? In the long run, supply is extremely elastic, like this. Supply curve is like this. Because new coffee trees will have had time to mature, the effect of the freeze will have disappeared. Price return to P0, like this. That is in the long run case, right? Now we go next slide. Understanding and predicting the effects of changing market conditions. Feeding linear supply and demand curves to data. Linear supply and demand curve provides convenient tools for analysis. Demand, supply. Given data for the equilibrium price and quantity, price, P star and Q star, as well as estimates of elasticity of demand and supply of ED and supply, price elasticity of supply, we can calculate parameters C and D for supply curve and A and B for the demand curve. The curves can then be used to analyze the behavior of the market quantity, right? Like this. So I'd like to use some graph, this one in there, right? Okay. Oh, that's fun. So in that figure, I cannot read. Quantity demanded is equal to A minus BP, right? And quantity supply is equal to C plus BP. From here, we know changing QD over changing price is equal to minus B, right? And supply curve, changing QS over changing price is simply the first derivative of this function, like this. And now think about price elasticity of demand is equal to, simply talking, changing in QD over changing P at equilibrium point, P star over Q star, like this, right? That is the definition of price elasticity of demand. And we know that this one is equal to minus B, right? And we can calculate Q star and P star, where this one is equal to this one, right? And price elasticity of supply is equal to changing price, changing quantity supply, multiplied by equilibrium price, equilibrium quantity. That is equal to D multiplied by, we calculated this one already, P star, Q star. Right? Right? That is explained here. Our goal is to find the values of the constants A, B, C, D in the supply and demand equation based on the known values for this one and this one. similar procedures when demand depends also on another factor such as income. So explained like this, right?